seems to be fate that tonight we are celebrating 10 years of An Evening with the Stars. 10 years of great NASA accomplishments, and in 2025, I'll be celebrating my 10th anniversary working at NASA. As a kid, growing up in Ohio, I would watch movies like Independence Day, Armageddon, and Interstellar. Though campy at times, these movies instilled in me the wonder and belief that the US and NASA could save the world from hostile aliens, deadly asteroids, and mass extinction from climate change. I knew I wanted to be a part of that team that would help solve many of the known and unknown problems we would face as a country. Growing up, I also had a fascination with materials, real and fictional, like the rare metal alloys showcased in many comic book and fantasy series. Vibranium of Captain America's shield, metal ore found in Thor's hammer, titanium gold alloy in Iron Man's armor, Mandalorian armor made out of Beskar, adamantium of Wolverine's claws, and mithril as found in Lord of the Rings. Now, all of these fictional metal alloys possess fantastic properties and strengths. And growing up, I always wondered when something like vibranium would finally be a real thing. When it came to real-life materials, I enjoyed collecting cool rocks. This is a true story. One Christmas, my parents unironically put rocks in my stocking. Some even looked like coal, and I was excited about it. There's an actual video of this moment if anyone doubts it's real. My other passions happen to be airplanes, science, and eating sweets. I believe this is perfectly captured by this image of me organizing my Halloween candy. I mean, come on. I look like a kid that was destined to have a career in aeronautical research, right? Oof, I can't believe I'm sharing some of these photos. I don't think my wife has even seen some of these. Growing up, I also remember hearing about all the fantastic technology the future would bring. Technologies that would solve many of the problems that plague society, like unlimited energy, faster space travel, massive space stations. These things don't currently exist because we don't have the materials to create these technologies yet. So, who is working on producing the materials that will be needed for the next revolutions in space technology? We are. Tonight, I'm going to show you how the NASA Glenn Research Center is at the forefront of producing the materials that will be used to create these fantastic technologies of the future. About 10 years ago, NASA had a meeting to discuss and prioritize the next year's aeronautics research budget. I ended up talking with an airplane engine designer about an issue they were having with these new 3D printed airplane component parts. The parts kept cracking when tested at their targeted high temperature. I said, well, we might be able to fix that issue. We're NASA, aren't we? I want to give a quick background on why we thought we could solve this specific issue. It goes back to work occurring at NASA Glenn all the way back in the 1980s. Back then, we learned that if you could add trillions of hard nanoparticles into a metal, you would achieve huge increases in its high temperature properties like strength, durability, and corrosion resistance. This type of metal was known as an oxide dispersion strengthened alloy, or ODS alloy. But what was the drawback? No one knew how to make it. Back then, we never truly came up with a way to make an ODS alloy that was economical or reliable. Then, in the 2010s, a new manufacturing technique emerged called 3D printing, where we literally use lasers to make metal parts layer by layer. When we tried this new technique to 3D print a copper alloy called GR-COP42, invented here at NASA Glenn, what we found is that it was much better and stronger when made by 3D printing than we could have ever dreamed of in the past. We were basically reviving an alloy NASA had developed decades ago to 3D print rocket engines. Now, the reason for this copper metal's higher strength had to do with how the laser scattered large hard particles in the metal during the print process. So we decided to revisit making those ODS alloys of the past But instead of using earlier methods that didn't work, we tried something new. We coated the metal powder with nanoparticles first. Here's a picture of the coated metal powder that I think looks like powdered sugar donut holes. Hey, told you I had a sweet tooth. It's kind of what it looks like. Well, we took that coated metal powder, we put it into our 3D printer, and we tried making ODS metal with it. And long story short, it worked. Those black dots are nanoparticles. And you can see how well dispersed they are in the metal when looked at under a microscope. And with all of our excitement in the lab, one of the worst things that could possibly happen did, the pandemic. We all got sent home. While stuck at home, trying to think about what we could do, we asked ourselves, what metal chemistry should we use for our new coating and 3D printing process? Can we design our own? Can we use computer models to help us? The answer was yes. Using computer modeling, we came up with a brand new metal recipe. As soon as we could get back in the lab, we took that metal powder, we coated it, and we started printing it with our laser. We immediately started testing at extremely high temperatures, 2,000 degrees Fahrenheit and above. That's about 5 times hotter than your oven at home. Now, at these temperatures, even our best high temperature superalloys will crack and break quickly. Here's how long it takes those superalloys to fail at 2,000 degrees Fahrenheit. And this is what we achieved with our new metal we are calling GRX 810. I'll be honest, our first discussions were not about how excited we were. We were trying to figure out if we had set up the test right. Then more data started coming in from independent labs, and we knew we had achieved something special. Fun fact, this is how that test I just described ended up failing. The much smaller GRX-810 sample was completely intact, and it was the much larger superalloy load rod that was holding it that cracked and broke first. I don't know if this has ever happened before in a high temperature test. I know I've never seen it happen. Our results were first published in Nature, one of the world's most prestigious scientific journals, joining the likes of other great discoveries like DNA and carbon nanotubes. Media quickly picked up on the story.
A Northeast Ohio engineer is being credited with an invention that could revolutionize how engines are made.
And NASA has recently signed 4 commercial licenses with major US industry partners to produce this metal at industrial scale. We are currently working with Carpenter in Reading, Pennsylvania, Elementum 3D in Erie, Colorado, Linde in Indianapolis, Indiana, and Powder Alloy Corporation in Loveland, Ohio. Oh yeah, remember that airplane part that kept breaking? It was the whole reason we started this project? Well, we 3D printed it using our new metal, GRX 810, and it worked. So what does this mean for technologies beyond GRX 810? Well, it means new materials that can handle radiation better. It means metals that can better withstand the heat of new propulsion technologies. And it means faster and more efficient air and spacecraft. This video is showing a hot fire test being performed at the NASA Marshall Space Flight Center using a 3D printed GRX-810 nozzle and injector and a 3D printed GR-COP42 combustion chamber, all alloys invented here at NASA Glenn. This success story is a direct result of the investment that this state and country have made to the NASA Glenn Research Center. And it only shows a fraction of the groundbreaking work being performed here. In fact, next, we could hear from Carlos, who will talk about NASA's efforts to again walk on the surface of the moon and beyond. So, where are we going from here? Well, GRX-810 is just one example of what can be made with 3D printing. We can now make complex parts that are all strengthened using these nano-oxides. I brought a 3D printed dragon made out of GRX-810 that you can check out later. Who knows? maybe this is my own type of vibranium, and we'll be 3D printing Captain America's shields out of GRX-810 someday. These are GRX-810 parts that we just made recently at NASA. Just 3 years ago, if a company had asked to make an ODS component like these, the answer would have been, it's impossible. That is what NASA does. We make the impossible possible. Who knows what amazing discoveries will come out of NASA Glenn next? I know, I can't wait to find out. Thank you.